Hey guys, welcome back for our 15th installment in our review series. We're coming down to the home stretch here, and we're going to look today at differential equations, what they are, some different ways that you might have to work with them, and some applications of differential equations. Remember, a diffie-q is simply any equation that has a derivative in it, right? A lot of times we see it, having an x and a y, so maybe already this f of x over g of y on the right. Where our goal is to figure out what y is equal to. So figure out the solution is the function that has that dy dx for its derivative. And there's a few different ways that you need to be prepared to handle this. And I want to just kind of talk to a quick brief overview of each of these and what they are. The first is a slope field. Remember that a slope field is a visual representation of the solution to a differential equation. So when you look at the slope field, and you look at each of the different directions and the different paths through that direction field, what you're seeing are various solutions to the differential equation. Remember, you should be prepared to create one by plugging in points and graphing those little slopes. You should be able to interpret a slope field, draw a solution through a slope field through a particular point, and match a slope field. These are not difficult to work with, and I think it's something that'll be pretty easy for you to review from our classwork. Okay, second thing for my BC only students is Euler's method. And remember, Euler's method is a way that using the derivative in a known point. So given, wait, it's not here. Given dy dx, this is why it's with our differential equations, and f of a is equal to some value k, we'll call it, you can approximate f of b, some new value, using various steps. Now, there's a few different ways that you can do Euler's method, but for my students, we learn the table. So I'm just going to remind you of what that table is. So our first column of the table is xy. Our second column is dx. Our third column is dy dx. And our fourth column is dy. The way that Euler's method works in a problem is xy is going to begin your first point, whatever you're given. So in this case, it would be a comma k. Dx is given to you in the problem in some way. That's your step size. Maybe it's having you go from 0 to 1 with 2 steps of equal size. So each step would be 0.5. So look to the problem. There's dx is going to be in that problem in some way. Dy dx comes from plugging your point into the given differential equation. And then dy comes from multiplying dx and dy dx together. Then you're going to take the changes. You're going to take dx and add it to a. You're going to take dy and add it to k and create a new point. And you're going to continue to do Euler's method until the number of steps has gotten you to the point that you are trying to approximate at b. Don't overthink this. Just take your time, go slow, and work through those computations efficiently, but also correctly. All right, the third part of this is solving a differential equation. So how do we actually solve a differential equation algebraically? And this is done through a process called separation of variables. So I'd like to do this with an example problem. So let's say you are given the differential equation dy dx is equal to y squared times 2x plus 2. And it is known that f of 0 is equal to negative 1. So the idea with the differential equation, if you are asked to solve it, and remember it's important to wait until you're asked to solve it, because a lot of times they'll say y equals f of x is the particular solution to the differential equation, but they don't ask you to solve. Make sure you look for those words that say find the solution or solve the differential equation to let you know to do this. Okay, step one, you're going to separate your variables. So I'm going to divide the y squared over to the left with dy, and I'm going to multiply the dx over to the right with the 2x plus 2. On an AP free response, this would get you a point, just for separating correctly. Then you will anti-derive both sides of the equation. 1 over y squared becomes negative 1 over y, and 2x plus 2 becomes x squared plus 2x, and then plus c. Don't forget the constant of integration, that's important. A general solution would leave c in the answer. A specific solution, we're actually going to solve for c, and I like to do that right now. So I'm going to substitute in the initial condition, 0 for x, -1 for y, which would give us 1 on the left when I plug in that -1, zeros for all these x's, so these go away, so we're just left with c is equal to 1. Once you have that, you put c back into the equation, and then we're going to solve for y to finish this thing off. So I'm just going to go ahead and swap these. I'm going to multiply the y over to the right times all of this stuff and then divide all of that stuff over. So we get an easy solution of -1 over x squared plus 2x plus 1. And that's it. So that's a basic example, but a good one for you to see on how to solve a differential equation. If this shows up on an AP free response, it's worth a good amount of points. So be ready for it and make sure that you separate those variables first, and don't forget the plus C. All right, the fourth thing I want to look at are some basic applications. And what I'm going to say about your applications that I want you to remember. Remember, we derived the whole exponential growth with the differential equation dy dt equals ky. And when we solved it, y became ce to the kt. This is useful knowledge to remember these quick versions or quick solutions when you work on multiple choice. But for free response, for the most part, you're going to be asked to solve the differential equation. So what I would look out for in your AP exam, if they go for an application to differential equations, is focus on the diffie-q that they give you, which they will. What is the application? And then when you have to solve it, just solve it like normal and put all your answers in context of the application given. It's important to know the different types that we went through and what their solutions look like. But at the same time, I think it's most important to know how to use separation of variables to solve and then interpret. So as you review your applications, focus on the solving. And we've done some problems like that to review that have applications to diffie-q. So hopefully you've got a good feel for what those could look like on your exam. Okay, the last thing today is for BC students only, this is going to deal just with the logistic differential equation. And the logistic differential equation gets represented two ways on the AP exam, typically. So dy dt is equal to, so our first way would be when we see it where there's some number k. And I'm going to write it like this, and I'll explain the difference between these two in just a second. The other way that we see this written, the logistic, would just simply be some number y times 1 minus y over. So a couple things I want to point out with this logistic. This value of m shows up in two places. It shows up either here, in this spot, m, a number minus y, or if it's 1 minus y over a number, it shows up here. Remember, this m represents the carrying capacity, which we'll talk about in a second, the carrying capacity. It will not show up here. So if it's in this form, this k over m will just be a fraction. It'll be some number. That's some constant of growth for this logistic. So always look out for the carrying capacity either here minus y or 1 minus y over the carrying capacity. Now, what does that thing mean? So what is important to know about the logistic? It's all about the behavior of the graph. So if you're looking at a logistic solution, so what is y, they're going to behave in this way, where they begin to grow exponentially, hit a point, turn, that's their inflection point, and then begin to go concave down and approach a horizontal asymptote. That value of that y value of that horizontal asymptote is the carrying capacity. What is the population approaching? In an application, this could be a limiting factor prevents a population from growing past a certain point. So it grows quickly at first and then begins to slow down and level off as time goes to infinity. That's the carrying capacity. You see this and you can interpret this from a slope field or a graph, or you just know what it would look like based on the differential equation that's given. That's important. So some things you need to know from the logistic. You won't be asked to solve the logistic on the AP exam, but you should be able to interpret it and interpret it within an application. So the first thing, what does the function, so let's say the solution is y equals f of x, right? Or not f of x here, let's call this f of t, since I'm putting a application spin on it. What is the limit as that time goes to infinity of f of t, the solution? Well, that's going to be the carrying capacity. So I'll call that m. The population will approach that horizontal asymptote as time goes to infinity. That's important for you to know. Second thing, what is the limit as time goes to infinity of the derivative, the diff eq? The diff eq as time goes to infinity will always approach 0, right? The slope is going to level off and approach 0. The third and final thing that I'd like to stress today is when is it growing the fastest? So when is it growing fastest? In a real world scenario, this typically occurs halfway to the carrying capacity. So if this carrying capacity is 10, this is the line y equals 10, that inflection point will be the rate of fastest growth occurs halfway at 5 in this case. Doesn't matter where you start, it will always occur at that point that's halfway up to the carrying capacity. So those are your 3 big facts. Remember, you recognize the logistic because of the y on the outside times the y here on the inside. That's a key characteristic of the logistic diff eq. Remember, in our class, we did solve it. That took about 20 steps to solve this with separation of variables. Focus instead your studying over these next weeks on interpreting the behavior of the logistic. Okay, guys, that's it for today. Please reach out if you have any questions or want any more specifics about diff EQs, and good luck with the rest of your studying.